All right, so there's a couple different ways to use functions in MATLAB, and three of them I know are pretty useful. So the main one is to use functions to write a function at the bottom of your live script, because you can't write them anywhere else. You can actually write several functions at the bottom of your live script, and they should all work fine. But you can't have any other kinds of code in there. So I'm going to make a new section by doing Control-Alt-Enter. That's how you can do that. By the way, if you make sections with like a plot command in them, it will just run. It'll just run any code that's in this section. So I can hit Control-Enter to run a block of code, and it will just run this part. So like, if I say this, it should give me a hi, but if I do it down here, like that, something like that, and I run this again, it won't run this piece of code. Very useful for when you have like a bajillion plots in one document. But functions. So what I'm going to do is I'm going to write a function that gives me just like three different powers of x. So we'll write a function. I'm not even going to name it right now. And I'm going to have, well, I am. Okay. So I want it to give me the first power of x. I want it to give me x squared, x cubed, and x to the power of 4 for some reason. So what this is what my function is going to return. So when I run it elsewhere in my code, I'm going to get handed this array of 4 different values. And then I'm going to say, I'm going to call it powers. That's its name. And it takes in a value of x. So this is like having a function f of x. Here, I'm going to write this elsewhere. This is like having a function f of x equals like some 4-dimensional thing, right? Because I'm returning 4 different arguments. So it takes in one value and it returns 4. That's what this is, except the function isn't named x, it's named powers, and I'm returning it in this kind of format. That's what I have here. Powers. I give it x, and it gives me back 4 different values. So I can just put those right here. So this x value, I have it listed here, but all this tells MATLAB is what values to grab from the code that, get out of my way, from the code that I write in here. It tells MATLAB what values to grab out of this code to be returned. So I could define some value y equals like x times x squared. Well, I need to define x squared first. So x squared equals x times x. I do already know what x is because I handed it into the function initially. I said powers of some number, and that number has been set equal to x. So I already have x. I don't need to say x equals something. X is here. But I do need to say x squared equals something. So x squared equals x times x. And you want to silence all the outputs in your functions because they don't need to say anything. But if I define something like y equals x times x squared, that's cool and all, but it's not going to end up being returned by my function because it's not put in this list of values to be returned. Oh, okay. So I'm going to define x squared or x cubed equals x times x times x. And then same thing for x to the 4. There. Okay, that's my function. And I already have x, so I don't need to do anything. And that's my function. That'll do what I want it to do. I don't need to, so it'll calculate these 3 values, and then it'll return them. So I can go up here, and I'm going to just say this is functions, right? This is the functions part of my document. I don't know. I think that's good practice to just say, okay, here's all the functions. So I can say, okay, give me powers of 5. I can run that, and it will give me, okay, well, that's the thing. It only gave me one number because it gave me the first one. And when you are returning several different numbers from a function, you need to actually basically just do this. The easiest way is just to find your, so you can just take this, paste it right here, fill in the blank, and then you will end up with these 4 values. When you have a function like this, your function knows about all these x squared, x cubed, x to the 4th powers, but the rest of your code doesn't. It's completely hidden away inside this little box called powers. So I'm making this list, I'm setting the values that are calculated by my function equal to this list. So I could name this something else like W, Z, Y, and I ran out of letters, so I'm just going to do YY again. I don't know, it's arbitrary. Doesn't matter. If I do that, then I get my values. Alright, so another way you can use functions is by writing inline functions. And these are really good, especially if you just have something short that doesn't need to be written out in like verbose detail, like the ones that you might put at the bottom of your code. And I use these in one place in homework 3, where we have this big system of equations, but each of these itself is, x dot is equal to vx and z dot is equal to vz. These are all really short functions or equations themselves, especially something like calculating the speed from x and z components, right? I don't want to have to type this out everywhere in my code, but I'm not going to write a big function just to do that. Better way to do that is to write it inline. So that's what I did in here. You can see here is the equation that does that. So this should give me the speed. It takes in parameters and the time. It doesn't need to. It's just because it's in a big system of equations. It's a very generalized form. But you see it takes the 2 Vx components and the 2 Vy components. That's what param3 and param4 happen to be. This is an inline function. And I can rewrite it over here in a more useful way. So inline functions, they do get a name. You put the name at the beginning, and then you say at. So we're saying, okay, I'm writing a function now. This function takes in 2 different values. So this is like saying f of x or y, f of x comma y. So I'm going to say vx and vy. And then what do I do with those values? I put it right here. So I'm going to say, okay, the speed, v, is square root of vx times vx plus vy times vy. And there we go. That's my function. If I try to run this, it'll give me this. What this is saying is, okay, what is useful is that now I can say, okay, what's the speed if I'm going 3 meters per second along the x and 4 meters per second along the y? That should be 5. And it is. So I can now just use v everywhere in my code instead of typing out this big square root every time. And you can actually use functions, inline functions, inside of each other as well. So that's what I did in homework 3 over here. So I have this big system of equations. It's 5 different equations. I haven't written 5 different functions, but you can see between these 2 brackets, I have semicolons. So this is actually a little mini system of equations. This is similar to what we did over in discussion 3 homework, where we have a system of equations with just 2 different equations. You can do those both at once. I don't exactly remember how this works, but you can take several equations and put them next to each other. It will all works. You can make vector equations here by just, instead of saying, okay, it's just one calculation I'm actually doing 2 calculations. This is just one thing equals another thing. There's no calculation happening here, but I could say 2 times. Okay, I'm doing 1 calculation here and another calculation here because I have a system of 2 different equations, or 5 different equations where I've just here's the full system. SysEQ is all of this, and all that it does with the 5 initial parameters that I give it, which are, I give it the initial x, z, vx, vz, and the initial speed, which I calculate by doing all this stuff and from these values that I give to the function. But what it does is it just calls these other equations that I've written. So I don't actually have any math happening in here. I've outsourced all of it to these other smaller parts that do the math for me. Like speed, calculate the speed, does it right there by taking the Vx and Vz, so the third and the fourth, 3 and 4, the third and fourth elements of this parameter vector that I'm giving it. It calculates the speed, and it gives it back to whatever functions might need it. You put a calculation in between two square brackets. You say what values am I going to hand to this calculation, and then what is the name of the function, and then you can just call it like that. And then another really useful way to use functions is to put them in a file, and then you can just copy and paste them around all that you like. This is really, really good if you're in modern physics lab right now and you have your linear fit equation. You can put this in a function. You save it as a .m. You click save as, and then you should be able to save it as a .m. That's a function file. And this is literally, there's nothing special about how this is written here. It's just, I've taken, I think it's from literally right, where is that? There's I haven't started that yet. Yeah, so I have my first analysis documentation here where I've decided to use my linear fit function. I've literally taken this code and I have just copied it into this file all by itself and saved it as a .m file. And then I can just take this file right here and I can paste it into, whatever folder I happen to be working in. You can specify what directory you're in up here. So if I'm working on homework 3 and I want to use a linear fit and I have written out my function for this, I can just put it in this folder, and then I can use it in my code. And I'm gonna make a demonstration out of this. I'm actually gonna go to, here. I want this in a file. I want to use this in future live scripts of mine, but I don't have to copy and paste it at the bottom of my file every single time. So what I'm going to do is I'm going to say, okay, this is a function now. I don't actually want it to be a live script, but okay, here's my function. I'm going to save it as a, you probably can't see this because I think I'm focused on the MATLAB window, but I'm going to save it as a .m file. It's saved as powers.m, and you'll see it right here. There it is. And then I get a file. I can edit this in MATLAB just like a live script. And I get this file right here, and I can copy and paste this into other folders so I can use it in my code. So if I wanted, I can comment this out instead of deleting it. And since powers.m is still in the folder that I'm working in here, because, okay, the way that you make sure that you're able to use it, you look at your directory up here, and MATLAB is looking at this directory and these files in that directory. It can see this file because it's right here in current folder. Okay, so I can still say, okay, what is powers of 5? And it'll call this function. And if I rename it to powers but with 5 s's, and I save and update that function, and then I try this again, it shouldn't work. There, that should do it. Now it doesn't know. Now it doesn't recognize power. But if I add 4 more s's, now it'll recognize it because that's the name of this file. I guess this name here doesn't actually matter, I guess. That's how you can use your functions in a file. So I can now put this file wherever I need it in the future. Very helpful for linear fit. Probably very helpful for other things that you'll have to do in the future as well. So that's how to use functions.